Hello my dear students, welcome to our today's class, and today we are going to revise our fifth chapter, that is heat. Okay, so yesterday we have completed our numerical topic. Okay, so now we are going to revise, we are going to a quick revision of this chapter. Okay, so here in the very first video we have learned about a latent heat. There we have seen one activity related to ice cubes burner. Okay, so from that the activity or the thing setup will look like this. Okay, so from this activity what we have learned, the observation which we got, that is the temperature of the mixture remains 0 degrees Celsius till the ice melts completely. Okay, if we continue heating, then what happened, even after conversion of all the ice into water, the temperature of water starts rising and it reaches to the 100 degrees Celsius. Okay, at this temperature what happened, water starts converting into steam. Okay, yes, this is the graph which shows time graph with respect to temperature. Okay, the temperature with respect to time. So here what happens, the graph in the graph, line AB represents what, conversion of ice into water at constant temperature. Here you can see this line AB where there is no rise in temperature or nothing. This is a constant, this shows a constant temperature where you will see नो राइज इन टेम्परेचर. टेम्परेचर जो है वो इंक्रीज भी नहीं हो रहा है, डिक्रीज भी नहीं हो रहा है, वो कांस्टेंट एक ही जगह पे है. सो दैट इज कॉल्ड एज, सो दिस line AB represent the conversion of ice into water at constant temperature. Then when ice is heated, it melts at 0 degrees Celsius and converts into water at the constant temperature. So what is melting point of ice? The constant temperature at which the ice gets convert into water. जब ice melt होके वो water में convert हो जाता है, that is called as what, melting point of ice. Okay, yes. Then here we have seen this graph where the heat energy absorbed at constant temperature during the transformation of solid into liquid is called as latent heat of fusion. Okay, then the amount of heat energy absorbed at constant temperature by a unit mass of solid. Okay, unit mass of solid to convert what, to convert into liquid phase. To convert into liquid phase is called as specific latent heat of fusion. Specific latent heat of fusion में क्या होता है, unit mass of solid to convert into liquid. Okay, and the only latent heat of fusion with उधर क्या होता है, solid into liquid, वहाँ पे unit mass नहीं होता है. ठीक है, once all the ice gets transformed into water, then what happened, the temperature of water starts rising. Okay, जब वो आइस है वो ट्रांसफॉर्म हो जाएगा किस में, वाटर में, तब क्या हो जाएगा, टेम्परेचर जो है वो इंक्रीज होना स्टार्ट हो जाएगा. ओके, लाइन BC इन द ग्राफ रिप्रेजेंट्स राइज इन टेम्परेचर ऑफ वाटर फ्रॉम 0 डिग्री सेल्सियस टू 100 डिग्री सेल्सियस. ओके, यस. So here the constant temperature at which the liquid transformed into gaseous phase, gaseous state. तो गैशियस स्टेट में जब कन्वर्ट हो जाता है तब क्या हो जाता है, वो बॉयल हो जाता है. ओके, उसके वेपर्स निकलने स्टार्ट हो जाते हैं. सो दैट इज कॉल्ड एज व्हाट, बॉइलिंग पॉइंट ऑफ लिक्विड. एंड द हीट एनर्जी एब्जॉर्ब्ड एट कांस्टेंट टेम्परेचर ड्यूरिंग ट्रांसफॉर्मेशन ऑफ लिक्विड इनटू गैस इज कॉल्ड एज लेटेंट हीट ऑफ वेपराइजेशन. एंड व्हाट डू यू मीन बाय स्पेसिफिक लेटेंट हीट ऑफ वेपराइजेशन, जब यूनिट मास ऑफ लिक्विड आ जाता है. ओके, द अमाउंट ऑफ हीट एनर्जी एब्जॉर्ब्ड एट कांस्टेंट टेम्परेचर बाय यूनिट मास ऑफ लिक्विड टू कन्वर्ट इनटू gaseous phase is called as specific latent heat of vaporization. ठीक है, yes. Then we have learned about a topic, regulation. Okay, here we have seen an activity related to ice and weight. Okay, so here what observation we got, that is, it is observed that the wire gradually penetrates the ice slab. वायर जो है वो आइस स्लैब को खींचने को स्टार्ट करती है, बट आइस स्लैब जो है वो अपनी जगह से हिलता नहीं है, इट विल रिमेन एट इट प्लेस. ओके, सो आफ्टर सम टाइम व्हाट हैपन, द वायर जो है वो खुद ही कम आउट हो जाती है, वो खुद ही बाहर आ जाती है ऑफ द लोअर सर्फेस ऑफ द आइस स्लैब. हावेवर द आइस स्लैब डज नॉट ब्रेक, तभी भी आइस स्लैब जो है वो ब्रेक नहीं होता. सो द फिनोमिनन इन विच द आइस कन्वर्ट्स इनटू लिक्विड ड्यू टू अप्लाइड प्रेशर, आइस जो है वो लिक्विड में कन्वर्ट हो जाता है व्हेन वी अप्लाई सम प्रेशर टू आइस. ओके, एंड देन इट गेट्स reconverts into ice once the pressure is removed, that is called as regelation. ओके, सो यहाँ पे मेल्टिंग पॉइंट जो है वो कितना हो जाता है, मेल्टिंग पॉइंट ऑफ आइस बिकम्स लोअर देन 0 डिग्री सेल्सियस ड्यू टू प्रेशर. दिस मीन्स दैट व्हाट, एट 0 डिग्री सेल्सियस ice gets converted into water. ओके, एज सुन एज द प्रेशर इज रिमूव्ड क्या हो जाता है, द मेल्टिंग पॉइंट इज रिस्टोर्ड टू द 0 डिग्री सेल्सियस एंड वाटर जो है वो फिर से आइस में कन्वर्ट होना स्टार्ट करता है. येस, सो हियर वी विल गेट वन काइंड ऑफ ग्राफ in anomalous behavior of water. The next topic is anomalous behavior of water. Here what happens, you all know that when a liquid is heated up to a certain temperature it expands, and when it cooled it contracts. Okay, but water के side में कुछ अलग हो जाता है, it has some different behavior. What is that? So water shows a special and exceptional behavior, that is, if we heat water from 0 degree Celsius to 4 degree Celsius, okay, it contracts instead of expanding. Okay, so at 4 degree Celsius its volume is minimum. ठीक है, 4 degree Celsius पे उसका वॉल्यूम कितना होता है, मिनिमम हो जाता है ड्यू टू कॉन्ट्रैक्शन. इफ़ द वाटर इज हीटेड फर्दर देन व्हाट हैपन, इट एक्सपांड एंड इट्स वॉल्यूम गेट्स इंक्रीजेस. ठीक है, yes. So the behavior of water between its temperature from 0 degree Celsius to 4 degree Celsius is called as what? Anomalous behavior of water. Okay, at 4 degree Celsius the volume of water is minimum. Here you can see it means that the density of water is maximum at 4 degree Celsius because density is equal to mass upon volume. तो जब डेंसिटी ज़्यादा हो जाएगी तब वॉल्यूम क्या हो जाएगा, कम, और जब वॉल्यूम कम हो जाएगा तब डेंसिटी जो है वो ज़्यादा हो जाएगी. ओके, येस, देन वी हैव सीन द स्टडी ऑफ एनामलस बिहेवियर ऑफ वाटर यूजिंग होप्स apparatus. Okay, so we have seen what is this mixture, this is called as freezing mixture. Okay, this is a thermometer. Okay, then what is this all things called, that we have seen in our day-to-day revision, day-to-day lectures, in the day-to-day tutorial videos. So this part we have learned thoroughly in our tutorial videos. Okay, this is the just quick revision. Okay, so here in this what observation we get, that is, during the study of anomalous behavior of water using Hope's apparatus, temperature T1 and T2 are recorded after every 30 seconds. ओके, सो T1 एंड T2 जो होता है वो रिकॉर्ड करते हैं आफ्टर एवरी 30 सेकेंड. सो द टेम्परेचर आर प्लॉटेड ऑन y एक्सिस, ओके, ओवर हियर, एंड टाइम इज प्लॉटेड एट एक्सिस. ओके, the graph shows that initially both the temperature T1 and T2 they are identical to each other. Yes, here you can see they are identical to each other. This graph shows something kind of fish like structure. Okay, yes. Okay, then here as the time passes what happen, temperature T1 of water in the lower part of the cylinder decreases fast. Okay, T1 जो है वो जल्दी से डिक्रीज होना स्टार्ट हो जाता है, एंड बिकॉज वो लोअर पार्ट में है. एंड व्हाट अबाउट T2, T2 ऑफ वाटर इन द अपर पार्ट ऑफ द सिलेंडर डिक्रीजेज स्लोली. सो T2 जो है वो बहुत धीरे धीरे जो है वो डिक्रीज होना स्टार्ट हो जाता है. ठीक है, yes. Then we have learned dew point and humidity. What is that? You all know that about 71% of water, earth is covered with what? Water. Due to the constant evaporation of water, what happened? Water vapor always present in the atmosphere. So from that we will come to understand that whether how what type of weather is there today. It is cloudy, it is rainy, or it is somewhat like very dry and that kind of. Okay, so the presence of water vapor in the air makes it moist. Okay, so moisture दिखाई देता है. Yes, and this moisture in atmosphere called as what? This is called as humidity. Okay. Yes, for a given volume of air at specific temperature, there is a limit on how much water vapor the air contains. Okay, if the amount exceeds the limit, then what happened? The excess of vapor gets converted into water droplets. So it gets converted into small water droplets. When the air contains maximum possible water vapor, it is said to be saturated with the vapor at that temperature. So वहाँ पे क्या होता है? Saturation होना start हो जाता है. If the air temperature is low, then what happened? It will need less vapor to saturate the air. If the water vapor in the content is less than that maximum limit, then what happened? It is said to be unsaturated. So this is all process of saturation and unsaturation of water. Okay, suppose that the unsaturated air at a certain temperature is taken and its temperature is decreased. A temperature is reached at which the air becomes saturated with vapor, that is called as dew point temperature. Okay. Yes, so the vapor content in the air is measured using physical quantity, which is called as absolute humidity, and the mass of vapor present in a unit volume of air is called as absolute humidity, and it is measured in kg per meter cube. So what is the formula for percentage relative humidity? Actual mass of water vapor content in the air in a given volume divided by mass of vapor needed to make the air saturated in that volume into 100. So this is the formula which is very important. Then what is the unit of heat? The unit of heat are what? Joule in SI unit and calorie in CGS unit. You all know that 1 kilocalorie is equal to 1000 calorie. Okay. Yes. Then the last point which we have learned about specific heat capacity, where we have seen this activity, that in the wax container iron, copper and lead, these three spheres are there which having some equal kind of mass. Okay, so from this what we have observed that the iron sphere goes deepest into the wax. Yes, then the lead sphere goes least. ओके सबसे कम, एंड द कॉपर जो है वो एकदम बीच में, दोनों के बीच में है, दैट इज इंटरमीडिएट डेप्थ. दिस शोज दैट फॉर इक्वल राइज इन टेम्परेचर द थ्री स्पीयर्स हैव एब्सॉर्ब डिफरेंट अमाउंट ऑफ हीट. ओके, तो ये तीनों ने डिफरेंट अमाउंट ऑफ हीट जो है वो एब्सॉर्ब की है. दिस मीन्स दैट द प्रॉपर्टी विच डिटरमाइंस द अमाउंट ऑफ हीट एब्सॉर्ब बाय अ स्पीयर is different for the three spheres? Yes, absolutely right. And this property is called as what? This is called as specific heat capacity. Okay, the capacity of heat to absorb, the capacity of the sphere to absorb the heat. Okay, the amount of heat energy required to raise the temperature of unit mass of an object by 1 degree Celsius is called as specific heat of that object. The specific heat capacity is denoted by small c. Okay, its SI unit is what? Joule per degree Celsius kg, and its CGS unit is what? Calorie per gram degree Celsius. Okay, so here are the some specific heat capacity of some substances is given, which is important related to your MCQ point of view. Okay, then if the specific heat of an object C, the mass of the object m, and if the temperature of the object is raised by delta T degree Celsius, raised by, okay, यहाँ पे ध्यान दो, raised by, then heat energy क्या हो जाती है? Absorb हो जाती है. जब temperature raise हो जाता है तब heat energy absorb हो जाती है, and it is given by m into c into delta T. But when in the same way, if heat energy of an object C, the mass of the object m, and the temperature of object is decreased by delta T degree Celsius, then heat energy वो है जो lost हो जाती है. Okay, then it is given by m into c into delta T. Formula same ही है, but यहाँ पे raised हो जाती है, यहाँ पे decreased, and यहाँ पे जो absorbed हो जाती है, यहाँ पे lost हो जाती है. Okay, then we have learned about heat exchange. What is heat exchange? Here the two objects are given, hot object and cold object. If heat is exchanged between the hot and the cold object, the temperature of cold object goes on increasing due to gain of energy. कोल्ड ऑब्जेक्ट जो है वो एनर्जी गेन करता है एंड हॉट ऑब्जेक्ट जो है वो एनर्जी क्या करता है, डिक्रीज करता है, एनर्जी जो है वो लॉस कर जाता है. ओके, यस. So the change in temperature continues till the temperature of both the object attain the same value. Okay, so we get one principle from this, that is heat energy lost by hot object is equal to heat energy gained by cold object. This is called as what? Principle of heat exchange. ये हॉट ऑब्जेक्ट है इसीलिए वो क्या करता है, हीट एनर्जी जो है वो लॉस्ट करता है, एंड ये कोल्ड है इसीलिए वो हीट एनर्जी गेन करता है. ठीक है. Yes. Then measurement of specific heat by using a method, a mixing method, using a calorimeter. Okay. So here we have seen the calorimeter is used. Then heating coil, some heat object is there, water is there. Okay, thermometer. Yes. So heat lost by solid object is equal to heat gained by water in calorimeter plus heat gained by calorimeter. But when the heat lost by solid object, that is Q, is equal to what? Mass of the solid object into its specific heat into decreased in its temperature. And the next is when heat gained by water. Okay, let's take an example that water is given. So here क्या आ जाएगा? Mass of the water, its specific heat and increase in its temperature, because heat जो है वो gain हो रही है. Okay, but the heat gained by calorimeter, तो यहाँ पे क्या आ जाएगा? Calorimeter. Okay, mass of calorimeter, its specific heat into rise in its temperature, because heat gain हो रही है. Okay, so heat lost by hot object is equal to what? Heat gain by calorimeter plus heat gain by water. तो यहाँ पे calorimeter भी है और water भी है, that is Q is equal to Q2 plus Q1. Okay, so this is all about your today's revision class. Please go through this, complete your assignments and submit your assignments on time. Okay, thank you students.